Unit 6, Day 53 Notes, Part 2. So number 2, the velocity of a particle that is moving along the x-axis is given by the function v of t, and there it is. This is going to be a calculator active problem. And so what do we know here? We know if the position of the particle at t equals 1.5 is 2.551, what is the position when t equals 3.5? So this goes back to the first example. So let me set that up. Okay, so this is a calculator active question. So I'm gonna, and over on the right side, I know I'm given that t at 1.5, the position is going to be 2.551. I'm trying to find out the value of the position when t equals 3.5. So that's all right. So now what I want to do is I just want to use the calculator to do this. And it's very similar to what we did when we were taking the derivative. And we're going to have to look at, for some of the older calculators, um, I'll write down what I believe it is, and we may have to check that out. So what I do is I still hit my math button, um, and I go up, and just like so, taking end derivative is 8, choice 9 is, hey, take the integral. Come back to 9. So hit enter, and on the new ones, it looks like this. So I just put what my lower limit is, 1.5, go up. This was 3.5, I believe. Go over. Now I put my function. Now if I have it in y1, I can just put y1, but I don't, so I'm going to type it out. So it's 0.5 e, so second e to the, now it says t, I could put as t, I just put it, and there's one variable, something like this, I just always put it in terms of x, times, now I have to do times, and again, if I'm using x for the first one, I got to use them for all of them, x minus 2, and this is being raised to the third power, I believe, yes. And then when we go out and then I was using my variable of integration as x. So when I hit enter, it's going to spit out what this integral is. So 15.919. That saves a lot of time, especially for something like this, decimals, all that stuff. If I believe it, I'll write this down in a second. Um, I think if I had to do it the old way, I'll write it down. So this is going to be 15.919. So if it's one of the older calculators and you're doing in the math button to find the integral, I think you put y1 or whatever that function is, you put that you're taking the derivative with respect, you're doing x is the variable of integration, and then I believe it's lower limit, upper limit. Someone with one of the older calculators, try that. If you can't get it, just leave the problem, and we'll figure it out in class. If you have your booklet, that'd be very helpful for me to look that up. But from memory, I believe it's like that. So remember when we did the end deriv, you had to do the function, what you're taking the derivative with respect to, and then what you were evaluating, the value you were evaluating it at. So it's very similar to that, except you need a lower limit and an upper limit. Okay, so try that. And now, just using our calculator, we can go through and solve this. Add 2.551 to each side, and we are going to get, hey, the position at 3.5 seconds is going to be 18.470. Okay, and that's pretty good there. And now when it says take the total distance that the object travels, so we're going from 1 to 5, and whenever I hit total distance, I'm thinking absolute value. So the absolute value of 1.5 e to the t minus 2, all cubed, finish the absolute value dt, and now I'm just going to put this right into the calculator. Let me just clean that up a little bit. That's supposed to be e to the t. Good, so let's put this in the calculator. I still have all this here, so now I'm going to try to, so I don't have to retype it. I'm going to do second entry. Okay, it comes back. I'm going to go all the way to the beginning. I'm going to try to just edit what I have there, so this will save some time. So this, let's go into the problem. All right, there we go. So delete, delete, delete. Oh, I have to go back, delete. So this was from 0 to 7. 0 to 7, that worked. Now what do I have to do? I have to add in that I'm the absolute value. So second insert, absolute value is in the math, and number, there you go, absolute value. And, oh, I might have to retype that whole thing. I thought I could do it and close the absolute value. Let me retype it. 0 0.5 e to the, and I'm going to put it all in parentheses. Let me clear that. Oh, when I cleared the whole thing. I'm going to start from scratch. Let's do that. All right, math. Choice 9 is to take the integral that we said from 0 to 7. 0 to 7. So let's go in here. I need to do math over a number, absolute value. There's my absolute value symbols. So here's where I said I'm going to put the parentheses. And I hit clear button instead of delete last time, and I shouldn't have done that. So try to always hit delete. 0 0.5 e to the t. So second e to the t. I know it's taking long, but I want to show it the right way. And again, I said I'm going to do everything in x, parentheses, x minus 2, all to the third power. And what are we taking the integral with respect to? That's, in this case, x. I know it says t in our problem, but I'm using x. And so now when I hit enter, it should give me the answer. It might give me an error. No, it didn't. Oh, and I'm using 0 to 7 for some reason, and the question is 1 to 5. So let me do that again. All right, so everything was right, except I used the wrong numbers. So that's going to be 1 to 5. So I'm now I can use my second entry. This will be easy fix. I didn't know if I needed a parenthesis. It put a parenthesis in there for me after I did the cube. I hadn't done that up above. So, all right, so I gotta go from 1 to 5. Sorry about that. I looked at the problem. Let's delete that. 1 to 5. So now when I hit enter, I should just be able to hit enter. It should be able to go. And perfect. 913.067. So now we know how to use the calculator. How to do the integral. So that's going to save us some time. Okay. So that'll be it for part 2, and we'll continue with this problem 3 on part 3.